Hello guys, welcome to Learn Chemistry with Dr. Muhammad Gul. Asimology is pleased to have you on board for Lecture 1. Today tutorial will cover some basic concepts like the definition of chemistry, matter, and classification of matter on different bases, difference between elements, compounds, and mixtures, and the concept of atoms and molecules. Okay, have you ever wondered why the stars shine? Why leaves change color in the fall? Why keeping foods cold slows their spoilage? How our bodies use food to maintain life? How a battery generates electricity? Chemistry answers these questions as well as countless others. How we define chemistry. Chemistry is the study of matter and the changes that matter undergoes. Or chemistry is the branch of science that deals with the structure, composition, and properties of substances and with the transformations that they undergo. One of the joys of learning chemistry is seeing how chemical principles operate in all aspects of our lives, from everyday activities like cooking dinner to more complex processes like the development of drugs to cure cancer. Chemical principles also operate in the far reaches of our galaxy as well as within and around us. Matter is the physical material of the universe. It is anything that has mass and occupies space. Property. A property is any characteristic that allows us to recognize a particular type of matter and to distinguish it from other types. Examples of matter: the smartphone in your hand, your body, the air you are breathing, and the clothes you are wearing are all samples of matter. Matter in our world is due to combinations of only about 100 substances called elements. Every change in the observable world has its basis in the world of atoms and molecules. Thus, as we proceed with our study of chemistry, we will find ourselves thinking in two realms: A. The macroscopic realm of ordinary-sized objects, macro equals large, and B. The submicroscopic realm of atoms and molecules. We make our observations in the macroscopic world, but in order to understand that world, we must visualize how atoms and molecules behave at the submicroscopic level. Chemistry is the science that seeks to understand the properties and behavior of matter by studying the properties and behavior of atoms and molecules. Atom, the smallest part of matter that can take part in a chemical reaction, is called atom. Atoms are the infinitesimally small building blocks of matter. Each element is composed of a unique kind of atom. We will see that the properties of matter relate to both the kinds of atoms the matter contains, composition, and to the arrangements of these atoms, structure. It was initially believed that atom is indivisible. But the modern world is familiar with the subatomic particles. Subatomic particles are the entities inside the atom. Well-known subatomic particles are electron, proton, and neutron. Can you imagine how small or big an atom would be? Atoms are unbelievably small. To take it in a perspective, 1 million carbon atoms can be arranged across the human hair. Molecule, an entity that can exist independently in nature. Based on the number of atoms, a molecule can be monoatomic molecule. Mono means one. These molecules contain only one atom. Examples are noble gases like helium, neon, argon, krypton, etc. Polyatomic molecule. Poly means many. Depending upon the number of atoms in the molecules, the polyatomic molecules can further be classified into a diatomic. Di means two. These molecules are composed of two atoms of similar or different elements. Examples are hydrogen and oxygen molecules. B. Triatomic. Tri means three. Some molecules such as water and carbon dioxide contain three atoms in their molecules. They are called triatomic molecules. C. Tetraatomic molecules. Tetra means four. If the molecule is made up of four atoms of similar or different elements, it is termed as tetraatomic molecule. Well-known example is the molecule of ammonia. Even apparently minor differences in the composition or structure of molecules can cause profound differences in properties. Polyatomic molecules can further be classified on the basis of kind of atom into homoatomic and heteroatomic molecules. Homo means same. Such molecules are composed of atoms of the same element. For example, chlorine molecule is made up of 2 chlorine molecules. The most important elemental form of phosphorus in terms of applications is the white phosphorus. It consists of tetrahedral P4 molecules, in which each atom is bound to the other 3 atoms by a single bond. Similarly, sulfur atoms form cyclic octaatomic molecules. On the other hand, heteroatomic molecules contain atoms of 2 or more elements. HCl is the common example, containing 1 atom of hydrogen and 1 atom of chlorine element. Similarly, water molecule is the example of heteroatomic molecule containing 2 atoms of hydrogen and 1 atom of oxygen. Methane molecule is made up of 4 atoms of hydrogen bonded to 1 atom of carbon. Classification of matter. Matter can be classified based on physical state and composition. According to the physical state, matter can be categorized into gas, liquid, and solid. Physical states of matter differ in some of their observable properties. First, gas. The molecules of gas are far apart and moving at high speeds. A gas, vapor, has no fixed volume or shape. It takes the volumes and shape of its container. It can be compressed to occupy a smaller volume, or it can expand to occupy a larger one. Second, liquid. Liquid molecules are packed closely together but still move rapidly. A liquid has a distinct volume independent of its container. It has no specific shape. It assumes the shape of the portion of the container it occupies. Not compressible. Third, solid. The molecules are held tightly together, but in definite arrangements. The molecules can wiggle only slightly in their otherwise fixed positions. The distances between molecules are similar in the liquid and solid states, but the 2 states differ in how free the molecules are to move around. A solid has both a definite shape and a definite volume. Not compressible. Changes in temperature and/or pressure can lead to conversion from one state of matter to another, illustrated by such familiar processes as ice melting or water vapor condensing. Second system of classification is based on the composition of matter. Matter can either be pure substance or simply substance, or it may be composed of 2 or more different kind of substances called mixture. A pure substance is matter that has distinct properties and a composition that does not vary from sample to sample. Water, H2O, and table salt, NaCl, are examples of pure substances. Mixture is combination of 2 or more substances in which each substance retains its chemical identity. Pure substance is again divided into elements and compounds. Elements are substances that cannot be decomposed into simpler substances. On the molecular level, each element is composed of only one kind of atom. For example, hydrogen, oxygen. Compounds are substances composed of 2 or more elements. They contain 2 or more kinds of atoms. For example, water is made up of hydrogen and oxygen. Elements. Currently, 118 elements are known, though they vary widely in abundance. For example, only 5 elements, oxygen, silicon, aluminum, iron, and calcium, account for over 90% of Earth's crust, including oceans and atmosphere. Only 3 elements, oxygen, carbon, and hydrogen, account for over 90% of the mass of the human body. Elements are denoted with the chemical symbols. The symbol for each element consists of 1 or 2 letters, with the first letter capitalized. These symbols are derived mostly from the English names of the elements, for example, C for carbon, Cl for chlorine, but sometimes they are derived from a foreign name like K for potassium, from kalium, Na for sodium, from natrium, Cu for copper, from cuprum, Fe for iron, from ferrum. Periodic table is a chart of the known elements. Compounds, chemical combination of elements make compound. For example, when hydrogen gas burns in oxygen gas, the elements hydrogen and oxygen combine to form the compound water. Water can be decomposed into its elements by passing an electrical current through it. Pure water, regardless of its source, consists of 11% hydrogen and 89% oxygen by mass. This macroscopic composition corresponds to the molecular composition, which consists of 2 hydrogen atoms combined with 1 oxygen atom. The elements hydrogen and oxygen themselves exist naturally as diatomic, 2-atom, molecules. Mixtures, physical combination. Mixtures is the physical combination of different substances. Components, the substances making up a mixture are called components of the mixture. Identity retention, each substance in a mixture retains its chemical identity and properties. Varying composition, a pure substance by definition has a fixed composition, while the composition of a mixture can vary. A cup of sweetened coffee, for example, can contain either a little sugar or a lot. Types of mixtures. A. Heterogeneous mixtures. Some mixtures do not have the same composition, properties, and appearance throughout. Rocks and wood, for example, vary in texture and appearance in any typical sample. B. Homogeneous mixtures. Mixtures that are uniform throughout are called homogeneous. Example: air is a homogeneous mixture of nitrogen, oxygen, and smaller amounts of other gases. Salt dissolved in water is another example. Homogeneous mixtures are also called solutions. Solutions can be a solid, liquid, or gas. The properties of nitrogen in air are like pure nitrogen because both contain the same nitrogen molecules. Here is the summary of classification of matter in the form of a flow chart. Ask yourself, is the matter uniform throughout? If the answer is no, the matter will be termed as heterogeneous. If the matter is uniform throughout, we will call it a homogeneous matter. Again, the homogeneous may vary in their composition and will be termed as solution or mixture. If the composition is not variable, the matter can be called a substance. A substance that cannot be separated into simpler substances is called an element, for example hydrogen, oxygen. If a substance is separable into further simpler substances, like water can be separated into constituent elements, hydrogen and oxygen, such type of matter is called compound. In the coming video, we will discuss the properties of matter. Stay with us and enjoy learning chemistry at your own pace. Thanks for watching.